The right, is that what we're
Yes.
talking about? The yeah, and the various clubs, but like good hosted it. God, yeah, good time. No, I'm man, okay, cool. Hi. What club were you representing there?
Dude, I'm not representing any club, but I mean, I got introduced because of the software engineering club. That was the
Oh,
first one that I came into.
nice. Well, welcome. I give these lectures every other weekend. I do like 5 to 6 hours of videos and then I upload them. And
Damn.
usually we have like closer to 7 or 8 people in here. Uh, on our best day, we had like 15. But today I announced way too late, even though they've been on the schedule for a while. So,
Mhm.
a bit of a
Yeah, I didn't really know that there was
Yeah.
anything happening until yesterday, and I was like, "Oh,
It's
okay."
all right. Yeah, they're every week. Dude, look at the high command channel,
Mhm.
and there's just the schedules in there. You can
Oh, they
see
are just always there. Okay,
they're
yeah, I see.
always there. They're always there, and I
Mhm.
update that periodically. But yeah,
Gotcha, gotcha.
well, Nick,
Very nice.
thank you. I'll give you a rundown. Basically, there's a big game jam that we're hosting. The Discord
Oh,
that you're in right now is not just UF. It represents like four different universities that have branches of Develop. But I am a UF student. But there is a separate like Develop UF server. But what I do is I try to provide content in here is like for everyone, but especially for FIT and FAU, which
I
are a bit smaller and kind of getting their feet off the getting off the ground. So um,
awesome. Oh, so
yeah,
Trevor, I see you're from FAU. Okay,
Mhm.
yeah.
appreciate it.
Um,
Yeah, and there's not like a special bot or anything. We just change our names. So,
oh yeah.
Okay.
People have been putting little prefixes in their names. Yeah, you can do whatever you want as long as it's just don't have like any slurs in your name.
So,
We definitely we dropped some people for having like hentai in their name or something
oh
in the
no,
past, like once or twice.
that is wild.
Yeah, classic.
and is this jam, are we organizing it? How, can you tell me more about that, Michael?
Yeah. It's so it's gonna be the weekend of Veterans Day. So November 10th, there's no school, so we're starting at like 3 p.m. November 10th, and it's gonna last 50 hours flat. Gonna end at like 5 p.m. on Sunday, and the organization of that. I mean, we'll organize people. We'll create like a designated time to get people into teams and like form groups and stuff. But the theming of it is sort of a war games. You'll see some. I'm actually spending around 4 hours tonight working on funny propaganda posters with the president of the FSU branch.
Okay.
But it's like
Awesome.
yeah, it's like war games. So the idea is like we kind of want FSU and UF to feel like they're competing with each other because like the UF branch has a good solid like 20 25 like really consistently attending members, I'd say, and the FSU branch has another like that many or something. So we're expecting to see 6 or 7 teams from each school, and then one team from like the aggregate of FAU and FIT that I've called Space Marines, and I don't know, we're sort of like organizing. Trevor's part of that, but like yeah. So the organization of it, I mean, there's. Have you ever used itch.io? Have you participated in like a game jam before? Do
I
you even?
haven't, man, I haven't.
Gotcha. Do
I'm
you know
new
you
to
know
it.
what a hackathon is?
Yes.
Okay. Well, it's like a hackathon for video games. It's like exactly analogous to a hackathon functionally.
You
Um,
have, like, X hours to build the game, so
yeah,
you can
precisely.
launch it.
Yeah, and you're welcome to use like external assets. It's like vaguely discouraged. Like you should probably and
Okay.
in the judging, we ask people to be very transparent about what they didn't make. So like, oh, because games are impossible, man. I mean, there's a reason that like GTA takes like 15 years to like make or something. I mean,
Mm.
granted, no one's making GTA in 48 hours, but I'm saying games in general are a very content rich thing to where like it takes a lot of it takes a lot to
It's
make
a small
something.
army.
Yeah, so it's fair to like use some external assets like animations and stuff
I agree.
in
I
48 hours.
agree. I would want to, like, use some models at least, because the modeling takes forever.
It's not fair to go and drop $1,000 to put you ahead of
Yeah,
them.
don't be the yeah, the guy that downloads the entire Unreal marketplace. No.
Okay, gotcha.
But yeah, Yeah, are you new to like completely new to game dev, Nicholas?
Yeah, man, I'm kind of new. I'm getting
Nice.
started. I've always wanted to do it. I've done a lot of research around the area, but I never actually got started concretely.
Right.
So that's what I'm hoping to do this
Right.
semester.
Sophomore, junior, freshman. What are you?
I'm a graduate student.
Freak! Oh, dude,
Yeah.
nice. Oh, we actually have a really cool grad student with specialization in computer graphics that hangs around on the UF Discord. His name is Random Past, but his real name is Michael K. Um,
Keep it random past. It's cool.
yeah, he does a lot of research on like pathfinding and like maze generation algorithms and stuff. Like
Dude, that's awesome. Yeah,
he's
because
a cool
what
guy.
I'm trying to get into is right now I'm just trying to make grid-based movement.
Okay,
So
okay.
that sounds really interesting.
What game engine are you using? Last question, I promise before I start.
So
Like,
I dabbled with Unity a little bit, but I kind of want to learn Unreal because I just know so much
nice.
C++ that I just want to use that.
Nice. Yeah, yeah. I Unreal is very quickly becoming industry standard, if not already. But some people would crucify me for saying that, so I'm like hesitant to say to say it. But I don't know, I don't like Unity. But that's just me. That's just me. I've been using Unreal since I was like really little, so I have like a special love of it. Most people seem to start with Unity, but somehow I discovered Unreal Engine 3 back when I was a wee little boy, and I fell in love with it. So that's
Yeah.
yeah. Anyways, okay. Well, here's the deal. Today's lectures do kind of it carry implications of like a little bit of past knowledge. I'm going to cover particle systems in Unreal, which you're not going to need much for, and version control. I guess more specifically with Unreal, which you also won't need too much context for. Um, but I'm going to start with talking about importing assets. That's what this first quick lecture is about, and this one's going to be a super short one. I'm going to try to for the next like 30-40 minutes cover the different types of data that go from a model or an animation or in general like an asset that comes from Blender into Unreal Engine, and some of the important things to be aware of that could like really trip you up when you're importing into Unreal. So that's what I'm going to get to right now. um but yeah, so okay, without further ado, so I've got Blender open. We got the default cube in here. I'm gonna delete it. X button. Hit the add menu over here. Do a mesh. Grab the monkey just so we have something a little more interesting to look at. And we're gonna talk about getting this into Unreal. So there's a couple of different layers of data that we need to be concerned with, that we need to be aware of. And I'm gonna explain how we can sort of put it all together in such a way that we can do it once and save it and never have to like sweat about checking the right boxes ever again. Um,
Is there a
awesome.
specific Blender version or
No, this is
just the latest?
yeah, latest version works. The stuff that I'm going to explain is pretty universal.
Gotcha.
So there's a few layers of data that every mesh has, and that data can be thought of as there's a few, right? We got the points, right? The vertices, and we have their connections, right? The edges, faces that bridge together those points. But there's a lot more metadata that sits beyond that. The metadata, which is like deeper under the iceberg, is we've got normals. So what are normals? Normals describe the direction that every face is pointing in. And you can visualize normals in Blender by switching to edit mode and hitting this drop down up here on the top right corner. And you just click normals right here, and you can look at surface normals, vertex normals. So here's vertex normals, right? And these little blue hairs that you can see now are visualizing the kind of average of the surrounding face. So if I move this up, you can see how that affects this guy over here. This guy's going to start tilting the more that I move this point up, like that. So it's yeah, those are vertex normals. You might think of normals in the calculus definition, right? In calculus, we've got let's take a look at Desmos, right? F of x equals like 15x, like 30 minus 15x squared over 3 over 10. I don't know, 10 4. There we go. Great little parabola, right? the tangent line is going to be well, we could draw the tangent line as like prime of x. This is the derivative, right? This is the slope at every point. So y equals x plus well, we would have to solve this for like a point that we can drag around, right? So hold on, let's do a point here, x comma y like that, and then we can move this point around. We can make the y value be f of x1, and then we can move this point along the curve, and then the tangent line is going to be oh god, how do we solve the slope intercept formula again? Y equals, we got y equals mx plus b, right? And then what you want to do is b is the y-intercept. You plug in the slope. The slope is going to be f prime at x1 x plus b, but b is the y-intercept. So right now, the tangent line is this line right here. The normal line is the line that runs perpendicular to this. We need to calculate b in terms of the x and y value. So where b is equal to y minus this stuff, which is going to be f of x, comma x, and then probably do this. Oh boy. I think we're getting the tangent line at every point. Gotta visualize this. Oh god. Let's do x1. There we go. There's the tangent line that we wanted. So we can move this around and see how the tangent line changes. The normal line is the line that's perpendicular to that. So what is perpendicular? It's -1 over the slope, right? So if that's the tangent line, then the normal line is negative this to the -1, which is the same as like 1 over. And it doesn't quite line up with our point, does it? But I guess it lines up at 0, 0. We'd have to reposition it to line up properly. New b value, right? Let's do b1, b1, and the y value suddenly becomes something else, presumably the what do we do? We do plus 1 over that. There we go. Okay. All right, normal line. So normal line, green line, that's the normal line, right? It's just, it runs perpendicular to the slope at any point of the surface. So if the surface is whatever, right, plus x to the 43rd power, this is the, there we go. That's the normal line at every point. So, yep, it works with everything. Those are normals. However, normals. Normals can change. You can fake them. So here's our, let's look at the face normals, right? There they are. Great. Face normals, beautiful. However, if we select all of this and we right click and we do, in object mode, we do shade smooth, the normals actually, here, we'll duplicate this. We'll kind of do a comparison. We'll make this guy shade flat. So these guys have the same amount of geometry, but the guy on the left has his normals blended. So they sort of smoothly transition from point to point. Blender is faking the normals. It's making them have like a gradient between surfaces. So what that looks like behind the scenes, the face normals are exactly the same, but the vertex normals end up getting, let's see. Yeah, see, this guy has split normals that are like aligned, but this guy's are actually split up. I don't really, there's interpolation happening across the vertices between these different hairs. This guy has like 4 little pink hairs that indicate the split vertex normals, whereas this guy's vertex normals are not uniform, and so there's interpolation here.
Do the normals like make up what would be a 2D image if you like just looked at it from a specific direction? Is that like the purpose of them
They're
or something like that?
not really. The purpose of them is to describe how the surface reacts to lighting. Fundamentally,
Gotcha.
lighting calculations in what's called a Lambertian shading model. So Lambertian
Hmm.
is the dot product of the light vector and the surface normal. And a dot product is I don't know if you have done like any calc that involves like dot products, but in terms of like here's what a dot product looks like. We'll do some dot product lighting here. Uh, um, let's do this. We'll do oh, hold on. Let me make this be matcap. Is there like a standard like lighting model kind of thing that we can do? Well, um, studio flat shading. Ooh, no, not
Well,
quite. Not quite what we wanted. Basically, the idea is like there's a single light in this scene, and maybe we can do like a shadow.
I mean,
I'll just show you like an actual detailed. I'm sorry. Here, dot product. we'll
but
do
at
a
the same time, I think I kind of get what you're saying with the normals. It's reflecting light, right? So obviously, what you see is always going to be the light reflected off a surface. You can't actually see it without any light, right? So it's however
Yeah,
the light would enter the camera from that given
yeah,
angle.
yeah. We're talking mainly about like whether a surface is lit or not. Here's
Hmm.
like so here's the light vector coming in, right
Hmm.
from the top right. Light vector is coming in like that. Surface normals are
Okay.
pointing like that. And
Yeah.
so if the surface normals are pointing in the opposite direction of the light, they get a value of 1. And if they're pointing in a direction that agrees with the light, they get a value of -1. And then everything around the like hemisphere gets a value of 0. And there's a sort of smooth interpolation, right? A smooth
Mm.
transition from a value of -1 to 1 based on whether the surface normals, which remember are the little hairs that come out of like
Hmm.
every face, are pointing in the direction of the light or not.
Okay.
Mathematically, it's the cosine of the angle between the two vectors. So again, like right, we can think of this as every
Oh wow.
oh gosh,
That's a lot.
hold on, my computer's lagging out because I have it on the CPU. There we go. Now we're chilling. Okay. Um. Oh. Oh. Ooh. I. Um. Like that. Individual origins. Scale these guys down. Alt E. Right. So, and then we can stop this visualization here so we can see it a little bit better.
What
These are
did
like
you
the.
just do?
I'm just creating little arrows. You can kind of see like the the vertex normal there, a billion little
Mhm.
arrows pointing the normal vector. Anyways, I just whatever, that's normals, right? So normals are metadata because they're not like they can be regenerated by Unreal Engine on import, but you also
Huh.
export them. So how do we export things from Blender? Let's go back to the, I kind of lost focus there for a second. Here's our monkey. We want to export this monkey. Let's say there's another monkey in our environment because we were working on another model, and we were also working on this guy over here, and maybe this guy has a just to give him some distinction. This guy's a mohawk. Sick. Um, beautiful. So if we want to export this guy, there's a few things that matter. First of all, notice that he is at the center point of our grid. That's pretty cool. It's a good thing. The other thing to notice is this little orange dot. That little orange dot that we see right there is the origin of the object. And so the object that is going to be exported kind of relative to that point. If I, in edit mode, move the entire mesh, the origin stays there. Watch what happens when I rotate it now. It's rotating around that point, right? So in Unreal Engine, this origin is treated as the center of mass. And if I exported it right now, and imported it into a scene, it would actually like flop around as if all of its mass is centered around this point. It doesn't, it doesn't like recalculate the moment of inertia dynamically or something. The center of mass is
Mhm.
is just the origin. In Blender, if you want to make the origin behave differently, you can right click and do set origin, and you can do origin to center of mass. You can do origin to center of like surface, origin to geometry, and you can see that the orange point has moved around a little bit. When I do origin to geometry, it moves it as the weighted average of just like points. Every point of the mesh is weighted heavily. And you can see how there's way more geometry near his face. So the origin has moved close to his face despite the large volume of his cranium. So anyways, big brain monkey, but the face weighs heavier because we did origin to geometry. So I'm going to do file, export, FBX. You got to do FBX for everything. FBX is like the industry standard for now. In the near future, we're going to see USD take over. NVIDIA is pushing USD heavily. Unreal Engine's beginning to adopt it. USD stands for Universal Scene Description, but for the longest time, FBX has been the industry standard. So I urge you to do everything with FBX. So we're going to do FBX, and we are presented with this interface. And in this interface, we get to pick where we want to export it to. I'm going to export it to my desktop. Actually, I'll export it under here. I'll make a new folder under develop for tutorial shenanigans. And on the right, the important stuff here is this interface on the right. I hope this is readable. There's a lot of settings here. One of the more important ones, limit to selected objects. So notice we have the monkey selected right now. We don't have this guy selected. We don't have this guy selected. We have this guy selected when we hit export. So selected objects is going to prevent us from exporting the entire scene. FBX supports more than just like meshes. It can support a light. It can support, all sorts of, lights, cameras, just fundamental parts of scenes. However, we only want to export the selected object. We don't care about visibility, right? Visible is in reference to Blender's ability to hide things, right? This little eye icon. You can also just press H when you have something selected to hide it. Alt-H unhides everything. So selected objects. This path mode, batch mode shenanigans, we don't care about it very much. Over here under object types, this is one of these menus where you can like click on one or you can hold shift to select several. So you can see it's able to export lights, cameras, armatures, meshes. All we're doing right now is we're exporting a mesh. So just a mesh, great. Gonna drop that down. Transform, scale. We want this to be in the same scale as Blender. Well, Blender exports in meters, I believe. So each of these like grid cells here is a meter. You can tweak these settings, right? So if we go to preferences and we go to system, I believe. No, interface. No, perhaps somewhere else. It's somewhere here. Somewhere here. I'll give it a second. If I can't find it, I won't bother. Text rendering, menus, editors. There's a setting about units somewhere in here. Somewhere in here, there's a setting on units. I'm kind of embarrassed right now. Hold on. God, it's somewhere in here. Navigation, key map, system. Could have sworn it was system. Units. Wow, I'm not able to find it right now. Oh, it's not there. It's here under scene, units, metric, unit scale 1. So okay, here we go. So we're in metric units by default, which is cool. Everything is in meters. So this like square right here is a meter by a meter. So this monkey is going to be a couple of meters wide. I have an add-on enabled called Measure It. It ships with Blender. You can just turn it on. But if I go, I don't have it enabled. Let me do edit, preferences, add-ons. I do. Wait, it's under view. That's right. My bad. Measure it, and then down here I can click segment, and then click show, and it draws this like line segment between the 2 points I had selected. So this monkey is 2.7 meters wide. Good to know. Okay. Anyways. Here we go. So scale 1, that's saying don't affect the scale at all. So this monkey's going to export as 2.7 meters wide. Up. What direction is up? The Z direction is up. Last I checked. So, might be worth declaring that. Z up. Forward. The forward vector is X. Positive X. So that's to the right. So let me just RZ90 this, and then apply all the transforms. Apply the rotation and the scale. And let me close this and then reopen the export thing. So now positive X, right? The positive X direction that's marked like here should be your forward direction when you're exporting to Unreal Engine. That's not necessarily true with like Unity, but it's true with Unreal. Export FBX. So mesh, selected objects, X forward. Notice that we have to do everything again. I'll show you a way that we can avoid that. X forward, Z up. Great. Cool. Geometry. So here we go. This is what I was talking about earlier. Normals. If we export only the normals of the faces, Unreal Engine will be forced to recompute those normals on the corners and decide whether it wants them to be smooth or not. I would rather export all possible details. So edge smoothing is the most detail. Apply modifiers. This is for the modifier stack in Blender, which is like all this stuff over here that you can do to a mesh. By doing apply modifiers, it's saying like apply any of these edits that you had going on. We're not going to worry about that. It doesn't really matter. Loose edges. This is like if there's an edge floating off in like, so here, I can select this edge, duplicate it, and now there's just an edge like floating in space. We don't want that. So I'm not going to export any loose edges. Triangulate faces. What is this talking about? So let's look at this monkey. This monkey is made up of squares, right? And here's the deal. Squares are great, but they don't contain all the data necessary to define a face. What do I mean by that? I mean that they have somewhat undefined behavior. If I move these 2 points up, notice that this is still technically a face, right? From above, it's still a square, but Blender is looking at it and it's deciding to insert a line here. It's actually implicitly triangulating this to have this shape. However, if we leave the triangulation to Unreal Engine might decide differently. It might say, let's do the other 2 corners. And if it picks these 2 corners, watch what happens. See, there's 2 different ways to triangulate every face. And this creates undefined logic, undefined behavior. So depending on the triangulation algorithm, you might get different results. That's why it is important to try to maintain faces in a planar state. Like you can see that these faces aren't perfectly planar. This guy right here has a little bit of like, he's a little warped. It's a little deformed. But he's close enough that it's not going to matter visually. But yeah, so what this is saying is like triangulate them in Blender. I don't really care about that. We don't need to. I'm gonna click tangent space. I might need to change that actually. We'll see. I might be making a mistake there. And I'm not gonna worry about armatures for now. I'm not gonna worry about animations for now. We'll cover that in a second. But I'm gonna do export FBX. So where was I? We were in ongoing develop tutorial shenanigans. And I'm gonna call this monkey.fbx. Export FBX. Now, here's Unreal Engine. Let's open up a project here. I'm gonna go ahead and open an empty project so we can, kind of appreciate that. Welcome, Prez. Hello. All right, let's see. So here's a new project, right? I'm gonna set it to be a blank project and not really worry about it. Here we go. It's spooling up on my other monitor. Here we go. All right. Okay. Here's Unreal Engine, right? So we've got the empty level open. Let's go ahead and try to import something. So we can click import. You can also just drag files straight in. So let's go to ongoing develop tutorial shenanigans. Monkey, open. And we get this prompt over here. Okay, let's look at some of these options and talk about them. Is our mesh a skeletal mesh? No, it's not. It doesn't have any bones. It's just geometry, just a skin. Should we build nanite for it? What is nanite? Nanite is Unreal Engine's really impressive system for having practically infinite resolution on meshes and really, really smooth LODs. LODs are level of detail versions of the mesh, and nanite manages to smoothly transition between high resolution and low resolution meshes in a way that is visually not discernible. So very cool. I'm going to turn that on. Should we generate collision for the mesh? This is an interesting one. I'm going to keep that on. We're going to talk about it. Advanced vertex color import option, whatever. We're not going to worry about vertex colors for now. There's a lot of settings down here under advanced. One of the more interesting ones under advanced, though, check this out. We've got import normals, right? So compute normals would have asked it to recompute the normals of all the surfaces. Import normals actually imports the normals of the surfaces. So that's like the smoothing, right? Is it going to be a smooth monkey or a bumpy monkey? Import normals and tangents. Tangents sort of describe not just the normal of the surface, but also a second vector that can be used in some other computations. I'm going to click import normals. We're good there. Normal generation method, there's, if we were saying compute the normals, these are two different normal generation algorithms. Great. Convert scene. Interesting. What does this do? Converts it to the Unreal Engine coordinate system. Yeah, that makes sense. Advanced. Override, names, materials, whatever. We'll talk about those. Import. I'm going to import. Y up. Interesting. Blender, FBX, whatever. Import. Okay. Monkey. Nice. Let's open this guy up. Yup. Here he is. Here he is. Good stuff. Notice X-axis forward, Z-axis up. Everything looks good there. You can see him. He's looking good. He's looking good. He has a material by default. So even though in Blender, this monkey was not given a material slot, it forces a material slot to exist for the entire mesh, naturally. Like, a material has to exist, otherwise, how would we render the surface? And it provides it with the default Unreal Engine material, which is this like grid pattern here that has this kind of interesting noisy surface. Very cool. Very cool. So there's our monkey. It's imported. It's great. There's a couple of things that are worth visualizing here. I think I said we want to show or to have collision. So let's see what collision we generated. If I click simple collision, this is the collision mesh that was generated for our monkey. Interesting, right? So what this is it's actually, well, it's a single hull. However, if we go over here under collision, we can see that there's, we can see the different elements. Here's this guy. Different collision types. We can regenerate collision, and we can also enable or disable complex collision. What is complex collision? Complex collision is the collision done per vertex of the original mesh. So if you want perfectly accurate, like per pixel collision of every vertex on the original mesh, rather than this abstract, like weird triangulation of the, like, whatever this thing is, this green thing, it's a convex hull. You have to click collision complexity over here and do use complex collision as simple, which is in essence saying enforce the collision to be done on the mesh itself. And you can actually select the outer collision and delete it. Now, another thing that I'm noticing is that I'm pretty sure our monkey's not centered. So let's take a look. Let me just drop the monkey in the world here. There we go. And so notice that even though our center is there, that center of mass that we were talking about, it's actually off center. I'm sorry, did someone say something? What's up?
Yeah, I had a quick question.
Yeah.
Do you always recommend us turning on that complex collision? Is that bad for performance?
It's
or
bad
do
for
we actually need
performance.
that?
Yeah, so it's bad for performance. It's important in some situations, perhaps, but like you generally want to avoid it. If you were making maybe a first-person shooter where you feel like it's very important to have accurate collision, you would turn that on. But even in first-person shooter games, there's usually like some steps that are taken to reduce the need for complex collision. Like if we look at, I think Team Fortress 2 was known for having some interesting hitboxes. Not T5F2, TF2 hitboxes. There was a way to like shoot through the gaps in characters. Right? Here's some collision boxes on the characters, so they don't use super accurate per pixel collision. Instead, they have, you see. Yeah, so in general, it's to be avoided, but like the computational cost is not that high if you don't have like a million monkeys tumbling around with their physics enabled. But this guy is off center. So if I was to do, delete the player start. If I was to enable physics on this guy and hit play, he trying to simulate physics. Error. Didn't like that. Didn't like that at all. But it has complex as simple collision. You may not be able to even simulate physics on something that has complex as simple collision. I think it might prevent you from doing that. That's really interesting. Yeah, it's yeah. Collision is it's a separate topic. There's a lot more to it too. There's like these collision presets where you can decide what channels interact with each other, and you can create your own custom collision channels. So like certain projectiles might pass through other projectiles or interact with only specific elements of your world, and you create channels that describe these and how they interact with each other. Let's focus on fixing the centering of this monkey. So the monkey's out here. And when we exported it, the center, it wasn't centered in our world, even though the origin is right there. So I guess I lied to you about the origin. I'm sorry about that, guys. It actually exports relative to the center of the Blender environment. So we're going to have to re-export this. A very quick way to recenter something is first you center the cursor by pressing Shift-C. Remember, this is the cursor right here. You can kind of position it in different places in your world. But when you do Shift-C, it is centered. And then the next step would be to do Shift-S, selection to cursor. Since we have the monkey selected, it's going to align its origin with the cursor. And now we can do File, Export, FBX, override the monkey. All of our export settings are still here. I'm just going to click Export. And in Unreal Engine, since it's in the same exact place, we can just click Re-import, and it will copy our import settings. So there we go. It re-imported it. It even shifted it over in the world. So now it's fixed. Our monkey is back. No floating edge. Everything looks great. That's great. That's great. So we've exported the mesh correctly. Notice that its geometry is smooth where it needs to be smooth. Like the lighting is interpolated here. It's not flat. If in Blender I did shade flat and did File, Export, FBX, override the other one, and then in here I re-import. There it is with flat shading, right? So again, that's because we checked this box right under here, geometry, smoothing, edge. This ensures that all of our data is exported, as well as tangent space. So yeah, tangents are, just to clarify here, remember, the normals are like, the normal is like this vector. The tangent is the vector that runs like parallel to the surface, kind of like this. Tangents are necessary to define like some properties of the surface, but they're not really. You don't need to be exporting them. You really don't need to. They can be computed relative to the normals. Anyways, okay, so yeah, there we go. Our monkey. Let's look at some other properties that are worth exporting, right? So any mesh has material slots. Material slots define where the colors go. I covered them in the past lecture. If we want to create material slots for this monkey, we do so by hitting the plus button over here. So here's a material slot. Here's another slot. And in edit mode, we can assign these to different things. So by default, this guy is all of the points. However, if we wanted these arrows to be a different material, we would have to select them like so. Maybe do this. Well, actually, faster way to do this, we select these points and then we do numpad plus. There we go. Now we've got the arrows selected and I can click assign. And now if I deselect everything and I hit select here, we can see that that second slot is associated with those arrows. We can also name these slots by providing them a material. So we can call this arrows, and we can name this slot and call it monkey. And if I export again, there's no settings related to materials in here, if I remember correctly. Right under geometry, yeah, there's nothing about materials that we need to select or check. It just will export them. In Unreal Engine, however, if we do re-import, can we? I know there's a way to adjust the import settings. Where is that? There's like import settings, asset, import settings. I could have sworn, whatever. Re-import. Yeah, but that's because we have the new materials. Okay. So now, under material slots, there's 2 slots when I did re-import. One for the arrows. We can highlight that. So here's the monkey. And here's the arrows. Monkey, arrows. Very cool. Arrows. Nice. So we can now color these differently, right? If we were to create our own material, we could color them differently. However, if I was to do a new import of the monkey, I'm going to delete it from here, import it again, and we look at these settings, you can see that under material, there's a material import method, and it says create new materials, create new instance materials, or do not create material. Create new instance materials attempts to copy some of the FBX properties into material instances, which I covered in an earlier lecture what material instances are, but we're not gonna do that. You're never gonna do that. If you do create new materials, it's going to look at your Blender settings, right? So Blender over here has material definitions, and materials can be defined in like a million ways. There's different types of scattering distribution functions that are made for Blender's path tracer. So like glass here describes how photons propagate through glass. Diffuse covers just like a principled rough surface and how photons scatter off of it. We're not using that. We're using this one's called principled, and what principled does is it combines the properties of physically based rendering, which is like roughness, metallicity, glossiness, and it puts them all into one big material. So we can define things like base color as being like turquoise. Oh, I accidentally just assigned monkey to the arrows. Let me go back here and assign arrows to that. There we go. So the monkey can be blue, and we can define how metallic it is. And we can define how specular it is, which kind of captures some of that shininess, and anisotropy, which we don't really see the effects of because the rendering mode isn't enabled right now, but this is like a CD has anisotropic properties. It means that like the light varies based on what direction you look at it from. Index of refraction, if it was transparent, like there's all these properties. The thing is, these properties do not line up one-to-one with Unreal Engine's own material properties. So if you do create new materials, it'll try to line them up, but it'll do a bad job, right? I'm going to do import, and it created 2 materials, one for monkey, one for arrows, and all it did was make them white, right? Because these are the properties in Unreal, and you can see they're not exactly the same as Blender's. Like, where's anisotropy? Where's like, clear coat? It's not here. You can enable them, but like it's a whole separate kind of situation. So generally, I would like you can import the materials if you want, but you're going to be wanting to reuse materials. So when that dialog comes up, you can click do not import materials. Okay, great. Last thing that I want to talk about. Actually, let's take a look over here. So we have metadata normals. I wanted to talk about yeah, we talked about this object scale normals and material slots. A little bit about import settings, right? So let me delete this and try to re-import the monkey. Here's monkey. You can see we've got build nanite checked. Under advanced, distance fields are forced on. So this is Unreal Engine 5 enforces the use of distance fields. Distance fields are these like bubbles around your mesh that describe the nearest point to the surface of your mesh. And if you go to the project settings and click, you look up generate mesh distance fields, it's toggled on, and that's because it's necessary for a lot of the lighting functionality in Unreal Engine. All of the fancy real-time lighting techniques that they do now revolve around distance fields. They're like a key part of the engine. So just something to be aware of. Yeah, let's actually, so let's look at the static mesh editor briefly as well to just talk a bit about some of the things in here. Under material slots, we've got the materials. This is where you change the default materials of the static mesh. Under nanite settings, so I guess we have all of this, all these statistics about nanite. We can probably can we do visualization of, let's see, show. Okay, we'll look at nanite in a second. Actually, sorry, but right here, enable nanite supports. This is like, will it nanite? Will it, have like reduce its detail the farther away that we get? So we can see the details of this on the top left over here. There's the nanite triangles, the fallback triangles, whatever. As we get closer, yeah, we're not really seeing any difference in the numbers over here. That's what I'm paying attention to. However, if we go over here, we can change some of these settings. We can look at keep triangle percent, maybe 48%. Now, our mesh has subtly changed. Some of the details have been reduced, which is pretty cool. If I put that back to 100%, cool. Yeah, just different settings here. I'd imagine that these probably kick in for a much higher resolution mesh. If we go to LODs, under LOD settings, we can increase the number of LODs. We can make 5 of them. Click Apply Changes. And what this will do is it will create a bunch of different levels of detail, and we can generate different ones. So if we go to LOD Picker, LOD Auto automatically picks it. LOD 0 is supposed to be the highest resolution one. LOD 1 has fewer triangles. LOD 2, even fewer triangles. LOD 3, even fewer triangles. And if I click, let's see. If I click, there's a way right here to force which LOD we show, right? So here's LOD 0, here's LOD 1, LOD 2, LOD 3. And what this is doing is it's for nanite primarily. So as we go farther away with nanite, it's going to drop it to as low as 64 triangles, which is insane. I mean, this is
triangles.
I'm sorry.
Like, instead of being lit, can you change it to nanite?
Lit?
Yeah, like in the top left, like the.
Over here. Yeah, perhaps optimization view modes. We could look at I mean, I'm paying attention mostly to the stuff up here. Let's see. Yeah, lit.
I only ask because it just looks like kind of the same.
It does. It does look the same from a distance. And this does have something to do with the distance at which these things kick in. So LOD4, you can see right here, LOD4 kicks in when it takes up less than 0.3% of the screen. So 0.00 to get to 0.0.
Well, you're currently on the LOD4. It only changes when you're on auto.
Yeah, but it doesn't kick in until
doesn't
nanite
activate.
kicks it in. So it's
Okay.
activating at this distance. However, if we go to, we're on LOD Picker, we're looking at LOD4, we can change the LOD settings. We can change the LOD settings for LOD4 to be, yes, it's using 6% of the triangles at screen size. Can we override the screen size? I know there's a way to override the screen size. I'm not sure how to do it, but there's a way to override what screen size the LOD kicks in at. But But yeah, anyways, there's various settings right here. Under import settings, the other, you can readjust the import settings right here. So this will kind of re-import the mesh with your different settings. For instance, if we go to, import normals, remember we were using flat normals, so if it regenerates the normals, they're going to be flat. If I make it do shade smooth, export FBX, and then back in Unreal Engine, I click re-import, which I think I can do. I'll do it from here. Right click, re-import. There we go. If under the import settings now, I do compute normals, and I hit save, and I say, I uncheck this, we should now be able to click re-import. And it computed the normals. There were some subtle changes, but I think it just generally went for a somewhat smooth shape. If I do built-in, re-import, if I do import normals and tangents, re-import, import normals, compute weighted normals. It's supposed to regenerate it. Anyways, whatever. Yeah, mesh settings. The distance fields
Does
is
Unreal do flat shading or no?
The shading is entirely a function of the surface normals, and I think nanite fallback. Oh, okay, here we go. This is how we show the nanite levels. Here's LOD4. There we go. By the way, sorry. Flat shading. No, the shading is a function of the normals. So we have to define whether it's going to be flat or smooth. In Blender, but in the shader you can manipulate these. So like in the materials over here, you can perform modifications. You can look at like vertex normals or vertex tangents and recompute the normals like this, and do some sort of modulo or something. I don't know, so some sort of thing to flatten them. You can do some math in here perhaps, but it's that first layer of whether they're going to be smooth or not is at the mesh level, and you export that from your program that you're using. You can define edges that are going to be sharp, so you can do mark sharp, and now that will be marked as sharp. Here, if I do shade, I think if I enable auto smooth for even big angles, yeah, there we go, and yet it's preserving the sharpness on those. So if I like mark this as sharp, there, you see what that's doing. And if I export this now, file, export FBX, export, re-import it in Unreal Engine, re-import. We should see it here. Yep, there it is. There it is. Normals. I'm still amused that when I go down here to the import settings and I decide to compute the normals. Oh, you saw the difference. Wait, import normals, compute. Oh no, nothing's changing. It's just like, yeah, it's not changing. That's really interesting. Yeah, man, I was under the impression that this right here is what decided if it would like try to recompute them. This might have to do with the fact that we're triangulating it in Blender, but I doubt it. I think it just always imports the normals as they're exported. Perhaps if we didn't export the normals at all, right? So perhaps if we under geometry right here, smoothing, we only exported like whatever normals and didn't export tangent space, export FBX, and we go to Unreal Engine, we do re-import. Now it looks to me like we do detail lighting. lighting only, perhaps. Yeah, it looks like things are kind of sharper everywhere. But man, I'm not sure what's going on here. Import normals, compute normals, no details were exported on the smoothing, so these edges aren't like uniquely sharper, even though we defined them to be sharper in Blender. Instead, it is just picking edges based on their concavity and defining them as sharp or not. Yeah. Anyways, whatever. I I won't bother anymore. But yeah, just these are some of the things to be aware of. Some things about debugging as well that I wanted to go over. If you're like trying to help your team and it's in the game jam and some mesh looks really weird. Some of the different debugging things that you can do is you can go in here and do nanite visualization triangles, and any mesh that has nanite enabled is going to look like that, right? So we saw it kind of change from the different LODs, right? If we go far enough away, you see it's like changing colors. It's picking a lower LOD level, and as we get really far away, it's going to drop it to as low as like 60 triangles or something. But when we get close enough, it smoothly transitions into the high resolution mesh. You can also go under, so if we go back to lit, we can do show visualize global distance field. So here's the global distance field. You can see it's this sort of blob that smoothly describes the closest point to a surface. So you can see how it's kind of like it merges the monkey with the terrain. Everything has a distance field in Unreal Engine 5 by default, unless you go to the project settings and disable it. But the distance field resolution varies. So if we look at, if I go to visualize, and instead of global distance field, we instead show mesh distance fields, you can see that the mesh distance field is actually a bit higher resolution, and we no longer see the terrain distance field. So the global distance field samples all the distance fields within like 100 meters of you and generates this 100-meter box of like of blobs that is for lighting that is near you. But mesh distance fields are what's used to produce that larger lower resolution box around us that has that distance field. So the mesh distance field can be much higher resolution, and the settings for it are found in here. If we change the distance field resolution scale to like 5, save this and close this out, it should regenerate the mesh distance fields. Maybe if I do re-import. Yeah, it'll try to make it higher resolution. That's generally the idea. But I suppose we're already... that's especially important for really thin surfaces. Okay, let me actually reduce the resolution. That's probably a better way to show it. Distance field resolution scale 0.01. Save. X that out. And then re-import this guy as well. I guess the resolution looks a little bit blurrier. You can see that in some of the lighting. Yeah. Look at that. He does look a little bit more blobby now. Maybe if I reduce it even more, distance field resolution scale 0.001. Save that. X this out. Re-import him. Yeah, it's progressive. I mean, he's blobby now. He's, I think, subtly more blobby than he was before, but not dramatically so. This matters more for really, really thin walls, or really thin surfaces that sometimes won't be captured by the distance fields. Generate mesh distance fields. If I check this, hit save. Doesn't make any difference because it's enabled globally, so they were already being generated. Yeah, that's what I wanted to talk about a bit. The distance fields, the materials. So let's see, what did we cover? Import settings, LODs, nanite, debugging using visualizers, object scale. Standard object. When in Blender you decide that you have a preset for how you're going to export everything, it's always going to be the selected object. It's always going to be the mesh. X is always forward. Z is always up. You don't want to have to change these settings every time. You might mess something up. You always want to export as much data as possible. You always want to export tangent space. You don't ever want to export loose edges. So what you can do is you can go up here and hit plus and make a preset. We can call this Michael's standard object. Yay, okay. And now, whenever you want to export something, this setting will be right here waiting for you. You just click it, and it does it. Restore operator defaults, that's the default settings, Michael's object, bang. Only meshes. If you're working with animations, skeletal meshes, there's a little bit more work that you have to do. But we're out of time, and I'm not going to worry about that too much. I think you guys can probably look up a tutorial if you're in the middle of a game jam. But yeah, I don't want to... the idea is to save you from that, but yeah, anyways, just be careful with your normals. Make sure that you export them all. Consider that the material slots, like you can name them. Whatever you do with materials in Blender won't transfer over. Just use the materials color to tell apart your different slots in Blender as you're like describing the materials. So you can just see the difference. Yeah, make sure that the object is centered, right? Just a little review here. It's only going to export the selected objects. If you select multiple objects, you can export them all together. Yeah, FBX is the export that you want to do. And then in Unreal Engine, all those settings, right? Nanite, the LODs, mesh distance fields. Those are some of the most important ones, but really just the LOD stuff. Remember, in Unreal Engine, if you don't understand something, usually you can hover over it and it explains to you what that thing does. For instance, like Nanite, like hover over, it's not helping me right now. Highlights this material, isolates the material. Preserve area. Like there's tooltips for things that need tooltips usually. A lot of stuff is self-explanatory, but yeah, okay. All right. I'm gonna pause the recording here unless there's like any questions that I can quickly answer here.
Hey Michael, I put some questions in the chat.
Yeah.
Read them out to you. That numpad selection thing that you did in Blender.
Yeah.
How does that work? That looked cool.
Oh, the way that I like expanded the selection. Yeah, it's when you select a point in Blender, or a face or whatever, and you do numpad, control numpad plus, it expands the selection. I can keep doing it, and it sort of like creeps over the mesh. And if I deselect the surface and do control minus, it reduces the selected regions. Probably see it a little bit better in wireframe. So now we have all these like disconnected regions. I do control plus, control minus. Yeah, and select a random face, control plus.
I wonder if it works without a numpad. Just realized I don't have
It doesn't. However, under preferences, there's under input, you can click emulate numpad, and it will turn the numbers, the 1 through like 0 numbers on the top of your keyboard to numpad numbers, because normally what those numbers are used for is like the
shortcuts, right?
They're used for some other shortcuts, like switching between face, edge, and vertex select mode is probably the most useful one. But yeah, I think it's worth it. When we do create materials, should we create it in Unreal or just try to import from Blender? Always create it in Unreal, never attempt to import it from Blender. Blender functionality will never transfer over in a meaningful way. Yeah. Yeah, so yeah, you make materials in Unreal Engine. The functionality in Blender is powerful, but it's made for Blender, right? It talks to Blender's API, so it doesn't line up with Unreal Engine settings. So you make the materials in Blender solely for the purpose of being able to differentiate the material slots and what faces they're assigned to, but you then like remake them in Unreal Engine using the actual like node-based system and all the different stuff in here, because the values don't exactly line up. Yeah. There we go.
Awesome. Thank you.
Yeah. Okay. Other questions? Chillin'. Now we're gonna get to the exciting stuff. We're gonna do particle systems. This is like way more interesting and fun. Okay. All right. Ooh, monkey reflections. Double reflections, nested reflections. Oh boy. We're truly living in the 21st century. Ray tracing. Incredible. Amazing. All right. Okay, yeah, I'm gonna close down the Unreal project. I'm going to end the recording to go